welcome to today's Friday Happy Math Hour. Today we're going to go over exam to review. I believe it covers chapters 5 and chapter 6 of Math 2412. Okay, I think we have, I have like 21 questions that more likely will be in your exam. I mean, some of them, but not every single one, but I chose the ones that I think most instructors would assign on the exam. Okay, guys, this is number 1. This comes from chapter 5. It says verify each identity. Okay, I'm going to do A part on this slide here and B part on the next slide. Because say you have tangent of x, cosecant of x equals secant of x. Okay, you're going to be working on the left side, and you have to match the left side to look like the right side. Okay, so it's like I tell my students, if you don't see nothing that's obvious from those identities, then convert everything to sine and cosine, and then see what we can see. Okay, so I think that should be our first thing to do. Okay, so we know that tangent, right, is equal to sine x over cosine x. So I'm going to replace tangent with sine x, cosine x. And cosecant is equal to 1 over sine. Secant x equal to 1 over sine of x. So I'm going to replace 1 sine x for cosecant. Right now, right, if you notice, the sine of x on top on the numerator and sine of x on the bottom at the denominator, that cancels and becomes 1. So we're left with 1 over cosine. And secant is equal to 1 over cosine. So that means 1 over cosine is equal to secant, right? So I got to match the right side. So again, you work on the left side to match the right side. So that's how you prove the identity or verify the identity. Okay, now let's do B. Okay, now again, we know that tangent of x, right? Again, there, guys, we don't see anything that's possible, right? To simplify, so we convert everything to sine and cosine. The tangent is sine of x or cosine of x, and my cotangent is equal to cosine x sine x. So replace cosine x sine x for cotangent x. Now here, guys, we gotta add them, right? We're gonna add them. So to add them, we have to find the LCD, which is the least common denominator. So the LCD, guys, is going to be cosine x sine x. Right? That's my LCD is cosine x, sine x, cosine x, or vice versa, sine x, cosine x. That means that the one on the left here, guys, the sine x over cosine x, what's the denominator missing to look like sine x, cosine x is missing the sine of x. So I'm going to multiply top and bottom by sine of x. You see, I'm not changing the value, guys, or the identity, because this is equal to 1, right? And on the right side, on the one on the right of the plus sign, right? So what's missing is the cosine of x, right, for the denominator. So I'm going to multiply by cosine of x over cosine of x, and let's see what happens. Right? On top, guys, we have sine squared x plus cosine squared x over sine x, cosine x. Now from the identities, I believe is called the Pythagorean identities. Sine squared x plus cosine squared x equals to 1. Okay, so that means it's going to be 1 over sine x cosine x. Now 1 over sine x is equal to cosecant of x, and 1 over cosine of x, right? 1 over cosine x is equal to secant of x, and 1 over sine of x is equal to cosecant of x. So here we have cosecant of x, and here we have secant of x. You see, guys, now it matches the right side. Okay, now let's do one more. Verify the identity. You have secant squared theta minus 1 over secant squared theta is equal to sine squared theta. I believe, guys, for this one, there's like two or three ways to get the answer. But I truly believe the shortest path is to write this. On the left, guys, this is the same thing as secant squared x over secant squared x minus 1 over secant squared x, right? In my opinion, that's easier to use. Okay. Now, secant squared x over secant squared x is equal to 1. And minus 1 over secant squared x is equal to the cosine squared x. because cosine of theta is equal to 1 over secant. So it's going to give us cosine squared x. Now, every time that you see something square, you look at the Pythagorean identities. And again, there's different routes to reach for the right side, right? I mean, to get the answer. But every student should use what's best for them. Okay. And I believe every time that I do this one, because this one is always on the review or the exam, I always do it like two different ways. Because I don't know, at times I feel like one way, and at times I feel like another way. So at times I do it like different ways. Okay. But here, guys, I decided to do it, this method here. So by using the Pythagorean identities, sine square u plus cosine square u equals to 1, right? We subtract cosine square u from both sides. We get sine square u equals to 1 minus cosine square u. You see, guys, so this on the 1 minus cosine squared x is equal to sine squared x. Right? But here, guys, I know it's theta, guys, and I'm sorry, but I just put x because at times theta, it's kind of hard to insert to the PowerPoint. Well, it's not hard, but it's more work. That's why I just use cosine. But let me go back. But this should have been x, guys, okay? Because I'm using x here, so that's my bad, okay? But that's a concept. But this should have been an x, because if I'm using x here, then this has to be an x, okay? So I'll make the correction later. But anyway, guys, this is the way you verify identities or prove identities. Hey, guys, this section, chapter 5 for 2412 is crucial for calculus 2. I don't think you'll see it as much in Cal 1, or maybe some of the identities, but verifying, you're going to use it in Cal 2 a lot. Okay, so make sure that you know how to use some of these, prove some of these identities. Now says find the exact values of cosine of 75 degrees and sine of 75 degrees. Hey guys, if we notice, 75 degrees is not a perfect angle in the unit circle, even though 75 degrees is in the unit circle between 0 to 360, but it's not one of those perfect triangles like the 45, 45, 90 and the 30, 60, 90 triangles. Because our unit circle is based on those triangles, and 75 degrees is not part of those triangles. So how do we get the answer then? So we're going to use the sum or difference, right? For example, if you use the sum, say sine of u plus v, right? It's going to be sine u cosine v plus cosine u sine v, right? So these are the formulas the formulas that you got to follow. Okay, so you're going to say, you're going to ask yourself, how can I get 75 degrees? Okay, right? You can use the plus or the minus, the sum of the difference, right? And we're looking for cosine, that's going to be one of these two here. There's my circle. Okay, 75 degrees, right, can be any combination that will give you 75 degrees. But the smallest one, that's addition, has to be 30 degrees plus 45 degrees. Or subtraction, you have a whole bunch of combinations, but I'm going to stick to 135 degrees minus 60 degrees. If you notice, 30 degrees is in the circle. 45 degrees is also in the circle, right? 135 is also in the circle, it's in quadrant 2. And 60 degrees is in the circle. So you have to get any combination that's somewhat different that will give you the degrees that you're looking for, okay? So we know that 30 degrees, right, is going to be the square root of 3 over 2, 1/2. Because I'm going to use the addition for this one here. The addition for the cosine and then the subtraction for the sine, just know it's the same thing. And then 45 degrees is square root of 2 over 2, square root of 2 over 2. Because they want the exact answer, and a mistake that students make is that they put in the calculator, guys, on the exams, and it's wrong because they don't give me the exact answer, because it's going to be some kind of decimal that's irrational. It never ends. It'll be like point something, 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 it never ends. Anyway, right, so I'm going to use the cosine of u plus v. So I'm going to let u be the 30-degree angle. I'm going to let v be my 45-degree angle, okay? So the cosine of 30 degrees plus 45 degrees is equal to cosine of 30 degrees, cosine of 45 degrees, right? I'm just following the formula here. Minus the sine of 30 degrees, the sine of 45 degrees. Now I'm going to go to the 30 degrees, right? And the cosine, is your x value. So for cosine of 30, it's going to give us the square root of 3 over 2. And the cosine of 45 degrees is also the x value for the 45 degrees, which will give us the square root of 2 over 2. Minus the sine of 30 degrees is a y value on the 30 degrees, right? The point, so it's going to be 1/2. And the sine of 45 degrees is a y value for the 45 degrees, which is square root of 2 over 2. Right, so on the, here on the left side, it's going to give us the square root of 6 over 4 minus the square root of 2 over 4. Right, so these guys, I'm going to combine them, so it's going to give us the square root of 6 minus the square root of 2 over 4. So this is my solution, guys. Okay. Okay, now, on the next slide, I'm going to do the sine of 75 degrees. Okay, again, same thing as a previous slide. Okay, but now, guys, I'm going to use either the sum or the difference. In this case, I'm going to use the difference, just so you know that it's the same thing. Okay, you should get the same answer. Okay, now, so 30 plus 45, right? Or I can use 135 minus 60 degrees will give us 75. So I'll be using the difference to find the sine of 75 degrees. So again, 30 degrees is going to be, hey, no, guys, my bad. This should be 60 degrees, okay? Because I was trying to, I duplicated the slide, and this should be 60 degrees, right? Let me see here. Well, that's for the plus here, guys, okay? But check this out, guys. I'm going to use, let me see here. I'm going to use the plus again, okay? U is 30 degrees, and V is 45 degrees. I believe on the other slide is where, on the other slide is where I'm going to use the difference, okay? Okay, now, so it'll be sine of 30 degrees plus 45 degrees, right? The sine of 30 degrees is going to be 1/2. Cosine of 45 degrees is going to be the square root of 2 over 2 plus the cosine of 30 degrees is going to be the square root of 3 over 2. And the sine of 45 degrees will be the square root of 2 over 2, right? So it's going to give us the square root of 2 over 4 plus the square root of 6 over 4. So what's the answer? The square root of 2 plus the square root of 6 over 4. I believe on the next slide is when I'm going to use, difference, okay, for the sine. Yeah, here it is. Now I'm going to use, the difference, okay, which would be the minus 1. Just so you know that we're going to get the same thing. Okay, everything's the same as before. So I'm going to use the 135 degrees minus 60 degrees equals 75 degrees. Now 135 degrees, right, is what we hear on the unit circle, which will give us, it's negative square root of 2 over 2, comma, positive square root of 2 over 2. And my 60 degrees is right here in the first quadrant. It's going to give us 1/2 and square root of 3 over 2. Okay, now, so I'm going to use the difference now, okay? So let U equal to the 135 degrees, and let V equal to the 60 degrees. So sine of 135 degrees minus 60 degrees equals to sine of 135 cosine of 60 minus cosine of 135 and sine of 60. So the sine of 135 is 2, and the cosine of 60 degrees is going to be 1/2, right? Minus the cosine of 135 is going to give us negative square root of 2 over 2, and the sine of 60 is going to be the square root of 3 over 2. Okay. So on the left side, it's going to give us the square root of 2 over 4. Minus and a minus will give us a plus. Okay, no, pues it will be minus. Let me see what I did here. Yeah, pues this will give us minus the square root of 6 over 4. Now this is going to turn to addition. You see, guys, that's the same thing that I got on the previous slide when I used the sum instead of the difference. So it doesn't matter what combo you use, you are going to get the same result. Okay, now number 4. I think these are going to be the double angle formulas. It says use the given information to find the exact value of the expression sine of theta equals to 8 over 17, and theta lies in quadrant 2. So quadrant 2, the sine is positive, and the cosine and tangent are negative. That's quadrant 2. Okay. So these are the double angle formulas. So this is for the double angle for the sine double angle for the cosine, but we're looking for the double angle of the tangent. Okay. So we know that sine of theta is equal to y over r. The cosine of theta is going to give us x over r, and the tangent of theta will give us y over x. Okay. So they give us the sine of theta equals to 8 over 17. Right? So which means my y is 8 and my r is 17. So I need to find my x, right? So to find my x, right, we have to use x squared plus y squared equals r squared. So just plug in the values. X squared plus 8 squared. X squared plus 8 squared equals 17 squared. So x squared plus 64 equals 229. Subtract 64 from both sides. It's going to give us 225. We take the square root of both sides. So x is equal to the square root of 225, which is equals to 15. So x is 15. Now, right, now we're looking for tangent, right? So tangent is y over x, which will give us 8 over 15. Right, but it's negative, right? Because tangent is going to be negative in quadrant 2. So we're going to follow the formula. Right, there's my formula. So again, there's a mistake here, guys, because if I'm using theta, all this should be theta, guys. Okay, I'm sorry about that. But the concept is there. So tangent of 2 theta is equal to 2 times the tangent, which will be 2 times negative 8 over 15, over 1 minus tangent squared. The tangent is negative over 15, and we square it. It's going to give us on top, on the numerator, negative 16 over 15. And the denominator is going to be 1 minus 64 over 225. Right? Now, on the bottom right, so we have to, we have to simplify the denominator. So 1 minus the 64 over 225 will be 225 over 225 minus 64 over 225, which will result in negative 16 over 15 divided by 161 over 225. So when you're dividing two fractions, the first fraction stays how it is. The division becomes multiplication. In the second fraction, you do the reciprocal, so you just flip it. Okay. Now here, guys, right? If you put into the calculator, guys, it should give you, well, check this out. 225 is 15 times 15, right? So 115 cancels with this 15. So I'm left with 16 times 15, which will give us 240. So this is my result, guys, negative 240 over 161. Okay. And at times, guys, some of these, right? I want you to do, this is the hardest one to do. This is where, the one that students have a hard time with. Because the sine is straightforward, sine of 2u. And also the cosine of 2u, you have 3 different options. And it's also straightforward. But the tangent is always like the hardest one. Okay, so that's why I did that one. Okay, now, number 5. Now we're solving, to solve the following equation on the interval from 0 to 2 pi. Because here, guys, with a bracket there, it means that 0 is included and 2 pi is not included. So it's going to be between 0, which is 0 included, and 2 pi. So leave the answer in terms of pi. Okay, so you have to pretend that, right, the unit factor. Okay, this is factoring. So the first thing to factor, guys, is what do they have in common? What's the GCF, or the greatest common factor? They have in common, both terms have in common a cosine of x. So I'll factor it out. So if I do that, I'm left with 2 cosine x minus square root of 3. And you can always check your work, see if it's true, right? Cosine of x times 2 cosine of x will give you 2 cosine squared x. And cosine of x minus square root of 3 will give us negative square root of 3 cosine of x. Now, right, now you're going to let them both equal to 0. You're going to be applying the 0 property theorem. So it'll be cosine of x equals 0. And 2 cosine of x minus square root of 3 equals 0. So then you go to the inner circle, right? So, the inner circle, guys, at this stage, you should already know it. Okay, now, guys, there's the video for week 1 shows how to memorize the unit circle. Okay, but I put it here, guys, just so you guys can see. It gets where is the cosine equal to 0 from 0 to 2 pi. You notice, guys, it's going to be at pi over 2, right? Because the cosine is 0 at pi over 2. And also at 3 pi over 2. So for the cosine equal to 0, these are my 2 answers. Now for the second part, let's solve for x. So first I'm going to add the square root of 3 to both sides. So we have 2 cosine x equals the square root of 3. We divide both sides by 2. So cosine of x equals to square root of 3 over 2. Now, where is the cosine of x equals to square root of 3 over 2? And notice, guys, this is positive, right? So the positive is going to be in quadrants 1 and quadrant 4 because the cosine is positive in quadrants 1 and 4. So let's go here, guys. So it's going to be pi over 6, right? And also 11 pi over 6. So these are my 4 solutions. Pi over 6, pi over 2, 3 pi over 2, 11 pi over 6. I just put them in order, right? That's how you solve trig equations with a given interval. Okay. Now this is from chapter 6 now. This is 6.1. It says use the law of sines to solve the right triangle. Round your answers to 2 decimal places. I believe I did this one, I think 2 weeks ago. Yeah. So here, guys, to solve it, you have to find the capital A. I mean, the capital letters are the angles, and the smaller letters are the sides. So let's see what's given, right? Angle B is 10 degrees. Angle C is 135, and little c is 45. So to use the law of sines, you have to have like a pair. I mean, by a pair, I mean you have to have the big C with the little c, or the angle C and the side C, because you're going to be able to use the law of sines. Okay, but first, it's easier to solve for angle A first, right? Because we should know that all the angles on a triangle, when you add them, is equal to 180. So to find angle A, we use A plus B plus C equals to 180. So angle A is equal to 180 minus B minus C. Let's plug in the values for the angles. So it'll be 180 minus 10 degrees minus 135 degrees, which will give us 35 degrees. So angle A is 35 degrees. Now we can use the law of sines, right? Because here, guys, right, we're going to use this pair here, the angle C and the side C, right, to solve for A. Because to solve for A, we're going to use little c over sine of C equals to little a over sine of A. Now let's plug in the values. So it'll be 45 over sine of 135 equals to A over sine of 35. We multiply both sides by sine of 35. So we get sine of 35 degrees times 45 over sine of 135 equals to A. You can just put this in the calculator, guys, just the way it is. You're going to get something like 36.502. I believe it says to round off to 2 places. So it's going to be 36.50. So little a is 36.50 approximately. Now let's find B. So find B, guys, we're going to use the same original angles, the same pair, right? Which will be little c over sine of C equals to little b over sine of B. Let's plug in all the values that are given. So now here, guys, I'm going to multiply by sine of 10 degrees, both sides. So sine of 10 degrees times 45 over sine of 135 degrees equals to B. Enter this in the calculator, guys, and it's going to give us 11.050. So it's going to be 11.05. So the angle is solved. I solved the triangle. Let's do one more of those. Number 7. Hey, guys, there's also for the section, there's also a part where it can be no triangles, one triangle or 2 triangles. But here, guys, let's do another one with 1 triangle. For that, there are certain rules, guys, because you look at the A and the B and the H. I did this last week. No, I think 2 weeks ago. So you can go back to that PowerPoint to maybe review, right, those rules. But this is right. It was six different ways it can be. It was 4 different rules for acute angles and 2 different rules for obtuse angle, something more than 90 degrees. I mean, on these rules, guys, all you do is compare the A and the B, or the A, the B, and the H. In this case, because side A is more than side B, it's going to be 1 triangle. Okay. So again, there's going to be 16 that we got to find all the angles and all the sides that corresponds to those angles. So what's given here is A is 42 degrees. Little a is 22 degrees. and little b is 12 degrees. Okay, now, so here, guys, right, they give us a pair, which is angle A and little a, side A. So this is the property that I'm going to use. But since we're looking for the angle, all we do is do the reciprocal of the original, of the formula that we did on the previous slide. I think the previous slide was little a over sine of A equals to little b over sine of B. But now, since we're looking for the angle, all we do is do the reciprocal because it'll be easier to solve for the angle. Okay, so let's plug everything in. So sine of 42 degrees over 22 equals to sine of B over 12. Right, so we multiply both sides by 12. So 12 times sine of 42 degrees over 12 equals to sine of B. Now, to solve for to solve for B, we take the arcsine on both sides. When we take the arcsine, on the right side, it's going to cancel the sign, so I'm there with B by itself. So you can enter in your calculator, guys, the arcsine, parentheses 12, parentheses 12 sine of 42 degrees over 22, close it, parentheses, close it again. You're going to get 21.406, round it up to two decimal places, we're going to get 21.41. Now we can find angle C, right? Because all these three angles must equal to 180. So angle C is equal to 180 minus angle A minus angle B. Plug in the values. So C equals to 116.59. Now I can find little c, right? By going back, not to because this formula is to solve for the angle. To solve for the side, it's going to be the reciprocal of the one to solve for the angle. So let's plug everything in, right? A is 22. The angle A is 42. We're looking for little c, and sine of c is 116.59 degrees. Multiply both sides by sine of 116.59. We're going to get sine of 116.59 times 22 over sine of 42 degrees equals to c. We use a calculator. So c approximately will be 29.40. See, guys, we solved the triangle. See, now let's do another one, but this is going to be law of cosines. Law of cosines comes from section 6.2. Because here, guys, we cannot use the law of sines. Why not? Because they don't give us no angle, right? So they don't give us no pair. For example, side A is 8 feet, side B is 19 feet, and side C is 14 feet. You see, guys, to use the law of sines, you have to have a pair. So that's why we use the law of cosines. Right? So to solve for A, guys, this is a formula to solve for A. It's going to be the arc cosine of B squared plus C squared minus A squared over 2 times B times C. So let's plug everything in. Right, so B is 19, so that's why it's 19 squared. C is 14, that's why it's 14 squared. And A is 8, that's why this is a formula that we're using. Over 2 times 19 times 14. You plug into the calculator, guys, how it is, into the calculator, you're going to get something like approximately 22.075. So it'll be 22.08. That's right, the answer for A. Now here, guys, we can go back, right? And now we can start using the law of sines. But now, because I think this formula is straightforward, so now let's use the law of cosines to find angle B also. Right? And this is the formula, guys. And all the formulas, guys, are on the slide, on the PowerPoint of 2 weeks ago. Okay? So we plug in all the values. Use your calculator. We get 116.8009. So it'll be 116.80. That's angle B. Now to solve for angle C, we use the sum of the three angles must equal to 180. Right, so angle C is equal to 180 minus angle A minus angle B. Plug in the values for angle A and B, and we get C equals to 41.12 degrees. So the angle is, the triangle is solved. Okay. Now we're going to do the last part of 6.2, which is the use of Heron's area formula to find the area. It says use Courant's area to find the area of a triangle with sides of A equals 43, B equals 53, and C equals to 72 meters respectively. So first, guys, I need to find S, right? Because this is a formula and it requires S. So S is equal to A plus B plus C divided by 2, which will be 43 plus 53 plus 72 divided by 2 will give us 684. Now we go back and plug into the area formula, right? So S is 84, A is 43, and B is 53, and C is 72. Plug everything in. Right, so simplify here, so then we multiply it out. We're going to get the square root of 1,281,168, the square root of that, so we're going to get something like 11,131.8869. I believe rounded out to two places, so it's going to give us 1,131.89 square meters. That's the result. Now, let's do 6.3 now. These are the vectors. I think I did this PowerPoint last week. It says, show that vector U and vector V are equivalent. See figure 6.12. There's a figure. So here, guys, right? I need to find the magnitude, which is the distance, and the slope for each vector. So vector PQ, right? Vector PQ, right? It's the same thing as the distance, right? So I'm going to use that one first. And that's a formula for the slope. So P is equal to 0, 0, and Q is equal to 3, 2. So vector U is equal to PQ. Okay. So now, right, in a similar manner, vector V is going to be RS, right? Point R is 1, 2, and point S is 4, 4. So now I'm going to find the magnitude or the distance of PQ. Right, my x1 is 0, and my y1 is 0. My x2 is 3, and my y2 is 2. So plug them into the formula for the distance. It will be 3 minus 0 squared. The square root of 3 minus 0 squared plus 2 minus 0 squared. It's going to give us the square root of 9 plus 4, the square root of 13. So the magnitude or the distance, which is the same thing, vector PQ, which is equal to U, vector U is equal to square root of 13. Now let's find the slope. So it's going to give us, right? So it's going to give us y2 is 2 minus y1 is 0. So it'll be 2 minus 0 over x2, which is 3, minus x1, which is 0. So it's going to give us 2/3. So I got the distance and I got the slope. In order for vector RS or vector V, they have to have the same magnitude or the same distance and the same slope. Okay, let's prove it. So x1 is 1, right? Is 1. X2 is 2. I mean, x1 is 1 and y1 is 2. X2 is 4 and y2 is 4. Plug into the formula for the magnitude. So it'll be 4, right? It's going to be x2, which is x2 minus x1, so it'll be 4 minus 1 squared, plus y2 minus y1, which will be 4 minus 2 squared. It'll give us 3 squared plus 4 squared, which will give us the square root of 13, right? Now for the slope, same thing is going to be 4 minus 2 over 4 minus 1, which will give us 2/3. You see, guys, they're equivalent. Why? Because they have the same length or magnitude and the same slope. That's why they're equivalent. Okay, now, number 11 says find the component form and the magnitude of a vector. So for that one, guys, right, you're going to let the initial point P be, because it's always the initial point, it's always the first point, 17, -5, which will be P1 and P2. And the terminal point will be Q, which will be 9 and 3, which will be Q1 and Q2. So P1 is 17, P2 is -5. Q1 is 9, and Q2 is 3. Okay, so this is a formula for the magnitude. So PQ is equal to Q1, which is 9 minus 17, over Q2 minus P2 will be 3 minus -5. It's going to give us -8 This is a vector, negative 8, 8. Okay, now that's a component form. Now for the magnitude, it's like the distance. Right, it's going to be component V1 squared plus component V2 squared. Right, I mean the square root of that, which will give us, right, this is component V1 and component V2. Plug them in there respectively. So it'll be the square root of negative 8 squared plus 8 squared. It's going to give us the square root of 64. The square root of 64 plus 64 will give us the square root of 128, which will give us 8 square root of 2. You always have to try to simplify it if you can. Okay, now how on the road do we go from square root of 28 to 82? Here's how. You try to find the factors of 128. You try to get the biggest factor that's a perfect square, which is 64. So the square root of 128 is the same thing as the square root of 64 times the square root of 2. The square root of 64 is equal to 8. So we have 8 square root of 2. That's my answer, guys. Okay, now, guys, I showed you guys an observation last week on how to find the component form of a vector. Okay? And I believe this observation, guys, is very easy to use. And you'll be able to get the vector like within seconds. Okay? And here's how. I'm using the same problem as before. Okay, but here's the observation, right? So it's going to be the initial point and the terminal point. So you're going to get the terminal point first, right? So that's Q. Then you're going to subtract the initial point. Okay, now, right, because it's minus, the P1 and the P2, they switch signs. Then what we do, right, we add them, and it becomes a vector. You see, this means it's a vector. The symbol right there. So you added Q1 minus P1 and Q2 minus P2. You see, this is a proof here. Now, let's do it for the same problem as we had in problem 10 on the previous slide. So it's going to be terminal point, which is 9.3, minus my initial point, which is 17, negative 5. So the point Q stays how it is, but point P, right, because it's minus, you're going to switch the signs. So it'll be negative 17 and positive 5. Now we just add them and it becomes a vector. So 9 minus 17 is negative 8, and 3 plus 5 is 8. So this is how you find the component form of the vector, right, by doing the observation. Again, this is a recap. It'll be terminal point minus initial point. You get the vector, right? Or terminal point, switch the sign, right? This way, you only do one step like I did here. Right, minus initial means you switch the signs on the initial points, and you get the vector. So this is helpful for the observation. Now for 12, I want you to find, let's see here, this is vector operations. I want you to find A, 2 times vector V, B, vector W minus vector V, and C, vector V plus 2 times vector W. So let's do the first part first. So 2, guys, 2 in this case on part A is a cascader, which means you're going to multiply 2 times every component in the vector. So I'll be negative 4, 10. That's the answer, guys, right there for part A. And here's going to graph it, okay? You first start, right? So you always go, you always do the first point, right, which is 2 times, right? So you go first from the initial, from the origin. You go to the point, negative 2, 5. And then you can add another negative 2, 5 vector, which means, right, is the rise over run, which is a y over the x. So it's going to be 5 units up and 2 to the left. You see, guys, that's how you draw it. So you will go here first, and then you will go up 5 and 2 to the left. You put a point there, and then you connect it, and that's your vector. That's 2 times vector V. Let's do part B. W minus V. Okay, here, guys, right? So with a minus, the signs on the second vector are going to switch. That becomes positive and a negative. Now, how you add these, you add the first component 1 with component 1 on both vectors, and component 2 plus component 2 on both vectors. That's your answer, guys. But here's an observation. Okay. Also with vectors, when you add, when you do an operation on vectors, I think it's wise to put them vertically. Example. vector W minus vector V. Right, first is vector W, right? For vector W is 3, 4, vector 3, 4. Then minus vector V, right, which means it will be minus vector V. Vector V is negative 2, 5. And then, right, so you're going to just carry over the vector V, the 3, 4. And here, guys, you're going to switch the signs. So it's going to be 2, negative 5. And then what we do is add them. So it'll be 5, negative 1. That's the answer, guys. So it's always wise to put them vertically, guys, because it'll be easier because you're adding the first components, like the first component on vector W plus the first component on vector V. Okay. And here's your graph. Right? We started with vector W first, right? Vector W is 3, 4, so we go 3, 4. You see? That's a point 3, 4. So this is vector W. Now we bring vector V, right? Because it's minus, right? It's minus, it becomes positive and negative, right? So this is vector V here, guys, the minus vector V, which means, right, it's going to go down 5 and 2 to the right, right? We go down 5 and 2 to the right, and then you will connect this dot with this dot over here, and then you will just draw that one, boom, and that'll be the answer, right? And then you connect from the origin. You connect it to the end of the point, and this is your W plus negative V. Vector W plus negative vector V. Okay. Now let's do part C. Vector V plus vector 2W. So again, here's the concept the way the book does it. Right, so give us negative 2, 5, vector negative 2, 5, plus you multiply 2 times 3 and 2 times 4. Then you add the first two components. You add the second two components, and you get 4, 13. Now here's the observation, right? So we're going to start with vector V, which is negative 2, 5. We're going to put them vertically, plus 2 times vector W, which will be 2 times 3, 4. This will give us vector V stays how it is, so it's going to give us vector 6, comma 8. Then you add, you get 4, 13. See, guys, I think it's, like I said, it's better to do it vertically, I think. Now here's your graph, okay? You started with a point, vector V, right, is negative 2, 5, so we go from the origin to negative 2, 5. And then 2 times vector 3, 4, right, will give us vector 6, 8. Which means I'm going to go up 8, right, because it's like the rise and the run. I'm going to go up 8 and 6 to the right. You see, guys, that's how you would do it, and then you would draw the line from this point here to where it ended. And then this would be my answer. Okay, that's how you draw them. Okay, now we're looking for the component. Now we're looking for the unit vector. Unit vector means that it's the links will be 1. That's why it's called unit. Okay, for 13, it says find the unit vector u in the direction of v, which is negative 2, 5, and verify that the magnitude is equal to 1. Okay? Need to find the magnitude of vector v. So it's going to give us the square root of negative 2 squared plus 5 squared. Will give us the square root of 29. Right, so this is the magnitude. Right, so we got the bottom part, and we also got the numerator, because the numerator is just vector v. So unit vector that we're looking for is vector negative 2, 5 over the square root of 29. So the square root of 29, guys, is like a scalar. It's like 1 over the square root of 29 times the vector negative 2, 5 will give us negative 2 square root of 29, comma 5 the square root of 29. So this is the vector that we're looking for. Now we have to verify that it's equal to 1. So for verification, guys, we find this magnitude. Right, so it's going to be negative 2 square root of 29 squared plus 5 over the square root of 29 squared. This will give us 4 over 29. This will give us 25 over 29. If you add them, it's going to give us 29 over 29, which is equal to 1. Now, guys, let's do another one of those. Okay, need to find the magnitude of vector v. So vector v is component 6, comma component 1. So the magnitude will be the square root of 6 squared plus negative 1 squared will give us the square root of 37. Right? So the unit vector is equal to vector v, which will be 6, negative 1, over the magnitude. So it's going to give us 6 over square root of 37, comma, negative 1 over square root of 37. So to verify that it's equal to 1, let's find the magnitude of vector u. Right? So it'll be 6 over square root of 37 squared plus negative 1 over square root of 37 squared will give us 36 over 37 plus 1 over 37 will be 37 over 37, which is equal to 1. That's what we verified. Now, 15 says that u will be a vector with initial point to negative 5 and the terminal point negative 1, 3. Where u is a linear combination of the standard unit vectors I and j. Okay, guys, so here we're going to do the observation, okay? So remember the observation is terminal point, negative 1, 3, minus, right? Minus p will be on point p, you switch the signs, you see, because it's minus. So it'll be negative 2, comma, 5. Now we add them, and it becomes vector. So vector u is negative 3, 8. Now, they want you to put it in linear combination form. But this is component form, and vector u is equal to negative 3i plus aj. This is a linear combination form. Okay, and that's it for that one. Now 16, right? We're doing the same thing as before, operation on vectors, but we're using I and j. They want us to find. They give us vector u is equal to negative 3i plus aj, and vector v is equal to 2i minus j. Find 2u minus 3v. Okay, now guys, this is the way the book does it. Okay, they do it horizontally because vector u is negative 3i plus aj. So it'll be 2 times negative 3i plus aj minus 3. Vector v is 2i minus j. Then you distribute, so it'll be negative 6i plus 16j minus 6i plus 3j. We combine the i's, right? So negative 6i minus 6i will give us negative 12i, and 6j plus 3j will give us positive 19j. Now, but I believe it's a little easier to do it vertically. Okay, this is 2u, 2 times vector u will be 2 times negative 2i plus 8j will give us negative 6i plus 16j. And then minus 3v is going to give us negative 3 times 2i minus j. You distribute will give us negative 6i plus 3j. And you add the i's, which is the first component, and the j's, which is the second component. So it's going to give us negative 12 plus 19j. That's your answer, guys. Okay, now 17. It says find the direction angle of each vector. So because here, guys, there's a formula to find the angle. The direction angle is determined by the tangent of theta equals to b over a. And the vector is ai plus bj. So in other words, the a, it goes with the I as a coefficient with the I, and the j is a coefficient with the b. So for a part, that's going to be the tangent of theta equals s quadrant 1, right? Because it was positive, which will be tangent of theta equals to 3 over 3. Now, how do we solve for the theta? We take the arctangent of both sides, right? So theta equals to the arctangent of 1. If you put that in the calculator, guys, it's going to give you 45 degrees or pi over 4. It depends if you have it in degrees or radians. Okay, now, so the first thing that you do, guys, is what's the quadrant that it's on, okay? And here's a point, 3, 3, right? And that's the angle that they're looking for. Now for part B, right? So let's do B now. The first thing is what quadrant is vector B on? This is going to be on quadrant 4 because this is positive and negative. It will be quadrant 4, which means to find the answer at the end, guys, you have to add 360. Okay, that's a rule. If the if the theta, guys, if tangent of theta is in quadrant 4, you add 360. If it's in quadrant 1, you leave it how it is. If it's in quadrant 2 or quadrant 3, you add 180 at the end. Okay? But here it's quadrant 4, so you're going to add 360. Okay, so then, guys, right, so we do the tangent of negative 4 over 3. So theta is equal to the arctangent of negative 4 over 3. You put in the calculator, guys, it's going to give you like a negative, right, 53.130102235. Right, if you add 360, the result is approximately 306.87. So that's your answer, guys. 306.87 is the answer. And here's the graph, right? 3, negative 4, right? Is like 3, negative 4 is a point there, which means this is the angle that we're looking for. Okay? Because this part here, guys, this part here was negative 53.1301235. So this is this angle that we're looking for. That's why you add the 360. Okay, now we're doing the dot product. I believe this is 6.4. For A part, I want you to find A dot product V times vector W. For B part, it's vector U times 2 times vector V. And C, we're just looking for the map U. Okay. So again, what you're doing, there's another observation, guys, for the dot product. I believe in last week's slide, I did the whole work. How you do it, right? But here I'm using the observation because it's easier. Because for the observation for the dot product, right, you put the first vector U, you put it let's put it vertically. Then it'll be that product. Then you put the vector V. So you're gonna multiply component U1 times component V1, and add it to component U2 times component V2, and then it's gonna give you a number, guys. It's gonna give you like a scalar or just like a number. When you use the dot product, it's gonna give you a value, not a vector. Okay. So let's do part A. So vector U, right, is negative 1, 3. And vector V is 2, negative 4, right? So the dot product will be negative 1 times 2 will give us negative 2. And 3 times negative 4 will give us negative 12, right? We add them, will give us negative 14. That's the answer for that part, right? But now we bring over vector W, which would be negative 14 times vector W is 1, negative 2. Right? We distribute the negative 14. This is going to give us negative 14, positive 28. This is the vector that we're looking for. Now for B part, we got vector U dot product 2 times vector V. So first I'm going to do 2 times vector V, okay? So there's 2 and vector V is 2, negative 4, so it's going to give us 4, negative 8. So now, right, vector U is negative 1, 3. Dot product vector 2 V will be 4, negative 8. Right, so we add negative 1 times 4 is negative 4, and 3 times negative 20, 3 times negative 8 will give us negative 24. We add them, will give us negative 28. Then for the magnitude will just be U is negative 1, 3, so it's going to be the square root of negative 1 squared plus 3 squared will give us the square root of 10. That's your answer, guys. Number 19, I want you to find an angle between two non-zero vectors. Okay, now here's a formula right there. So, right, this is what we're looking for, the angle between two vectors. So this is your formula, again, right? So this will be like in 4 parts. The first part, we're going to find the product rule of U and V. Second part, we're going to find the magnitude of U. In the third part, we're going to find the magnitude of V. In the fourth part, plug it in, and you find the arc cosine or the inverse cosine. Okay, you need to find out the product of the vectors and the magnitude of each vector. So here we go. So vector U, right? Dot product vector V is going to give us 12 plus 15 will give us 27. So I already got the numerator part of the formula. Now we're going to find the magnitude of vector U. which will give us 4 squared plus 3 squared, will give us the square root of 25, will give us 5. Then the third part, we find the magnitude of v, which will be 3 squared plus 5 squared will give us the square root of 34. Now we plug in everything into the formula. That's going to be 27 over 5 squared root of 34. And we plug into the calculator because that's the way it is. So we get approximately 22.17 degrees. Right? And here's the vector, right? So this angle is 22.17 degrees. Now, this is, I believe this is the second to the last one. You're saying, find the projection of u onto v. Okay. Then write u as the sum of the two orthogonal vectors, one of which is a projection of v into u. Okay, so this is a formula. So W1 is equal to the projection of u onto v, right? This is a formula here, guys. U dot product v over the magnitude of v squared. So we need to find the dot product of the vectors and the magnitude squared of vector v. Okay. So vector u is 3, -5. And vector u is 3, -5, and vector v is 6, 2. So again, for the dot product, we're going to use the observation. So 3 times 6 is 18. Plus -5 times 2 will give us -10. So it will be 18 minus 10 will give us 8. Now I need to use the magnitude of v, which will be 6 squared plus 2 squared will give us the square root of 40. Right? If you square it, it's going to give us 40. So I already got the numerator and denominator. So let's plug him in. Right, so we plug him in, right? So we got 8, because the dot product of u and v is 8, and the magnitude square of v is 40. This reduces to 1/5. 1/5 times 6 will give us 6/5, and 1/5 times 2 will give us 2/5. So this is your solution. Okay. Now, right now I want you to write the sum of the orthogonal vectors, one of which is a projection of u. So here, guys, we're looking for a W2, which is u minus W1. My vector u is 3, -5, right here from the beginning. And W1 is the vector that we just got right now, the projection vector, which will be 6 over 5, comma 2 over 5. So if we subtract 3 minus 6 over 5 will give us 9 over 5. If we subtract -5 minus 2 squared of 5 will give us -27 over 5. That's why this is my solution. Okay. Now comes how to use them like in real life. Okay, here's how. This 21, I think this is the last one. It says a 200-pound cart is on a ramp inclined at 30 degrees, as shown in figure 630. What force is required to keep the cart from rolling down the ramp? Okay, so we're looking for the force. Hey guys, this vector here, guys, right? Vector F is going to be 0i plus minus, it'll be 0i minus 200j, right? Because this is 200. Now, vector V, right? We have to find vector V. So vector V is going to be the cosine of 30 degrees I plus the sine of 30 degrees J, right? Because it's 30 degrees, this is 30 degrees here. So go to the inner circle, right? So 30 degrees is equal to square root of 3 over 2, 1/2. So it's going to be V equals to the square root of 2 over 2, the square root of 3 over 2i plus 1/2 J. Okay, now, right, here we go. For the projection of F onto V, there's your formula. So I'm going to find the dot product of F dot product V. My vector F is 0i minus 200j, and vector V is the square root of 3 over 2i plus 1/2 j. Right? Remember the option? We multiply the i's, which would be 0 times square root of 3 will give us 0, and negative 200 times positive 1/2 will give us negative 100. So it's going to give us negative 100 will be the dot product of vector F and vector V. Now I need to find the magnitude of vector V. Right? Vector V is square root of 3 over 2, 1/2, right? So we square both the square root of 3 over 2 and the 1/2. It's going to give us the square root of 3/4 plus 1/4 will give us the square root of 1, which will give us 1. So hey guys, so this part here, guys, in the parentheses will just be negative 100 and then times vector v. Vector v is the square root of 3 over 2i plus 1/2 j. So multiply 100 times both components. So it's going to give us negative 50 square root of 3i minus 50j. Right? Now for the second part, guys, what it means here, guys, what the force is the magnitude of vector W1. Right? So the magnitude of vector W1 will give us negative 50 square root of 3 squared plus negative 50 squared will give us the square root of 7,500 plus 2,500 will give us the square root of 10,000, which will give us 100. So the force is 100 pounds of force. And I believe, guys, that's it for this PowerPoint, for this review. And I believe most instructors will give you on the exam some of the problems that were here. I mean, more than likely, they're going to give us something very, very similar to what's here. Okay, guys, thank you, guys. If you have any questions, I can answer them for you. But for now, let's go back to your host.